Hi, everybody. Welcome back to Rockwell Process Consulting. Today, I wanted to talk about an example with reverse osmosis, RO, and the application of that water. So a few years back, I was working in a refinery, and they were interested in reducing their water usage. So I got looking into how they were applying water across the facility and looking into the boilers and the cooling tower. uh, they were using reverse osmosis RO water to feed their boilers to create steam, which is pretty typical. However, what was atypical was that they were using the reject water from the RO and using that in the cooling tower. Now, that may seem on the surface like a good idea to use that water so that it doesn't go to waste. So what they were doing is they were putting that into the RO, or sorry, into the cooling tower, and that was their makeup water for the cooling tower. Now they were actually putting in a significant amount of RO reject into that stream, so they're actually overflowing the cooling tower because they're putting so much RO reject into that. And they thought that was actually a good thing because the RO reject is low quality water, high in hardness and ready to scale. Well, that was actually the biggest part of the problem. They were scaling up a lot of their heat exchangers prematurely and quite quickly, and their blowdown on the cooling tower was extremely high because they were using that RO reject water as makeup water. Now, a couple of things with that. Number one, the RO reject, you should be running that so that you're right up to the point where you're almost scaling the RO, but not. So you're running kind of near the ragged edge on your RO, or maybe slightly below that to protect the RO. And that water is just about ready to scale. So if that water gets any more concentrated, or the pH goes up a little bit, potentially, that can scale. And that's going to cause a lot of problems. So the best thing to do with that water is always to just send it down the sewer. And the argument from some of the engineers there was that, well, you're putting it into the cooling tower water, which is also made up with city water, and so you're diluting it down. Okay, that's true. However, by putting it into the cooling tower, you are not only diluting down the RO reject and making it better quality water at the same time, and by a result of that, you are also making the cooling tower water that's cycling around worse and lower quality by putting that RO reject into it. So yes, what they said at the beginning of making that RO reject more dilute and better quality is true. It's also true at the same time that they are making their cooling tower makeup and overall cooling tower system water quality worse. And they are getting that water quality of the whole system closer to needing to sewer it to blow it down faster. And so they were actually sewering more water faster out of the cooling tower because they were already putting water that should have been going to the sewer straight into the cooling tower. And that was also allowing or causing the water that they were putting into the cooling tower, all of it needed to be treated for pH and hardness, scaling potential, and corrosion inhibition. So they're putting all those chemicals in there to then just be sent basically straight down the drain. So it's a waste of all those chemicals. Your cooling tower cycles, if that's a metric for you, is going to be lower because you're putting worse quality water in that should be going straight down the sewer anyway. So if you have an RO and you're maybe not 100% sure of what's going on with it, maybe take a walk out there and just make sure that reject water is in fact going straight down the sewer. If it's not, schedule maintenance to get it piped down the sewer as quickly as possible. And at that point, you're going to need to come up with a new plan of how you're going to feed the RO. I'm sorry, the cooling tower, and if your feed water volumes, pumps, chemical treatments are going to be adequate for having just your freshwater source being your feed water for the cooling tower. So if you have any questions about that, I know I covered a lot there. If you have any questions, feel free to leave them below or reach out to me directly. And if there's anything else you can think of for questions that you might have on water treatment or refining, I'd be happy to answer those. So feel free to reach out, and we'll see you on the next one.